Today's topic will be Newton's first law of motion. To begin with, we first need to understand what a force is. A force is simply a push or a pull. And there's two general types of forces. We think of contact forces and action at a distance forces, which is another name for a field force. Um, Contact forces arise from actually contacting something like kicking a ball or hitting a tree with a car or something like that. Probably not a good example because you can get hurt, but still. Uh, but field forces don't require contact. Those would be like gravity. A ball will fall towards the earth without actually being touched by the earth. Or magnets. You can get metal to move with a magnet without actually touching it. Okay. Arrows are used to represent forces, and the reason is because once again a force is a vector, just like acceleration was a vector and velocity was a vector and displacement was a vector. And the length of it has to do with how much magnitude it has. The arrow direction will tell you what direction that particular vector is acting in. And as you can see, the length of this vector here, the 5 Newton vector, is 1/3 that of the 15 Newton vector. So it makes sense. All right. Mass is a measure of the amount of stuff contained in an object. You can measure mass or compare mass on a platform scale such as the one shown. Well, weight is how this mass is affected by gravity. And we'll talk more about this later. This is like, standing on a scale that is measuring weight while the balance measures mass. Okay, let's talk about physics before Newton. Basically, people believe that rest was a natural state of motion. And after learning Newton's laws, and you look back at what they thought of before Newton came along with his formal laws, it kind of made sense as well. So they believe rest was a natural state of motion, which kind of makes sense. A cart doesn't move unless you push it. It stops moving once you stop pushing it. But then people will say, well, how about a cart rolling down a hill? Well, the simple answer there is the hill is pushing it. Okay? There were two types of forces that we thought of before Newton. They were called violent forces. This would be like a normal push or a pull. And natural forces. For example, smoke rises and carts roll down hills. Okay, then we have Galileo. Galileo said a ball will always try to reach the same height it was released at. So what he did is he took a highly polished bowl and put a marble on one edge of it. And he theorized that it should reach the same height as long as we can discount friction. And since it was highly polished and there was very little friction, it did indeed reach the same height. But how about a really long ramp? All right, same idea. It should keep on going to the same height because there's nothing to stop it. How about a very, very long ramp? In other words, it never reaches the same height. Kind of like this one here. What should happen? Well, it should continue on forever because it can never reach the same height. So it's always trying to reach the same height, but it never can. So it keeps on going. This was later formalized by our friend Newton in his first law. An object continues in a state of rest or in a state of motion at a constant speed along a straight line or a constant velocity unless compelled to change that state by net force. All right, so what is a net force? The net force on an object is the vector sum of all the forces acting on that object. For example, you have a 4 Newton object pulling to the left and a 10 Newton object pulling to the right. That can be written as a net force of 6 newtons to the right. And the SI unit for force is called a newton, which we'll look at it in a moment. So once again, the forces can be in two different directions, and this can be summarized by taking the vector sum of the two, using Pythagorean's theorem and the inverse tangent. So mathematically, the net force is written as the sum of the forces, where the Greek letter sigma denotes the vector sum. So this idea here is called a sigma, and it means sum. Okay. Sometimes Newton's first law is called the law of inertia. So what is inertia? Inertia is the natural tendency of an object to remain at rest or in motion at a constant speed along a straight line. I also like to think of it as the amount of laziness of it, how hard it is to get it to change whatever it's doing. Mass of an object is a quantitative measure of inertia. So the more inertia something has, the more mass it has. And the SI unit of mass we know is called the kilogram. Okay, an inertial reference frame is one in which Newton's law of inertia is valid. In other words, the object is not it's not accelerating, and nor is the reference frame that it's in accelerating. Okay, and that's pretty much it for Newton's first law. We'll learn how to apply Newton's first law later in the chapter.